Welcome to NoWiki Maths. Let's have a look at some math. So today we're going to be looking at factorizing, and particularly one type of factorizing called difference of two squares, also known as dots, the difference of two squares, the shorthand version. So let's get straight into it. The first thing we want to talk about is the rules. Now I would maybe recommend pausing here, writing these down for yourself. These are important. It is always up to you to decide what type of factorizing you're going to do. And if you can know what to look for, the factorizing becomes much easier. So let's talk about the rules. Rule number one, there must be two terms. Not more than two, not less than two, two and two only. Both of those terms have to be perfect squares. Now, perfect squares can come in two forms. Either if it's a variable, then it must have an even power. So here are some examples. X squared, x to the power of 4, x to the power of 6. Any even power will be a perfect square. And if it's a numerical value, then it needs to be a perfect square number. That just means any number that can be square rooted. So 9 can be square rooted, 3 times 3. 16 can be 4 times 4, 25 is 5 times 5, and so hopefully you get the pattern here. So a number that can be square rooted or the product of two same numbers. So 2 times 2 gives me 4, 4 becomes a perfect square. The second thing we need to worry about here, or the third one should I say, is this negative. So we have two options. Either we can have something minus something. So remember we said here two terms. So one term minus another term. If not that setup, then it will be a minus plus. But notice again that even though we don't have a sign here, this is a invincible plus. So there's only one minus and there is only one minus. So it can be there in between or it can be in the front, but it should only be one negative between the terms. And then sort of how we do this, or how we set up, is we say we're going to create two brackets. Both will have the square root of each term, and then we'll alternate the signs. So let's have a look at some examples. So to start with the basic ones, we first going to ask ourselves, is there two terms here? Yes. Right, so let's think. Two terms, the better you get at this, the less you have to do this, or the quicker you have to do it. But do we have two terms? Yes. Are they squares? That's my next question. Yes. That's an even power. That's a square number. So we're already happy with the two. But the biggest one is there a minus or a negative? And in this case, there definitely is. There it is there in the middle. And so now I can do my difference of squares. And it's very, very simple. We open two sets of brackets. We square root each of these things. So that becomes 3 times 3, and this becomes p times p. And all we do is we put one of each in the bracket, and we put and we alternate our signs. Now the order of the signs doesn't make a difference. It can be in the first bracket. So just to give you an idea, I could have done it like this. And these two mean exactly the same thing. Now, why does this work? So if we just take a minute to think about FOIL, and so we multiply the p and the p, I get p squared, but this is where it gets important. I actually get p times 3, which gives me plus 3p, and this gives me minus 3p, and let's just finish it off with those two, which gives me the minus 9. Now, what you should hopefully notice is these two terms here, the middle terms, they cancel each other out. Now, the only way that will happen is if they are different signs. If they're the same signs, they will either add to give you 6 or add as negatives to give you negative 6, but they won't cancel out, and so we need them to cancel out. Let's have a look at the next one. We'll do this one a little bit quicker. Notice for me, the difference here is I have still two terms, still a minus, even power, perfect square, just the order is different. In my first example, I had a variable first, then the number. Now I've got the number and the variable. It does not make a difference at all to our setup. So we're going to open up two brackets. 9 times 9 gives me 81. X times x gives me x squared. And all I do is I fill in the sign in between. Alternating, one must be minus, one must be plus. Right, let's have a look at this next example. And I've put a little star here. And I just want you to notice that the order is different. Here, both of these first two examples had a minus in between the terms. Now my minus is in the front. So you have two options. Option number one. So as I was saying, option number one is to rearrange this and make this 4 minus x to the power of 4. That is now in an order that we're happy with. So that's same as sort of our standard form. The second thing we need to notice here is that this is a power of 4 and these were powers of 2. So still meets my requirement of an even power and actually makes it much easier if I do it like that. So I open my two brackets, square root of 4 is 2, a 2 in each bracket. The difference here now is instead of x, it's going to be x squared times x squared. Because remember, when we multiply like bases, we add our exponents. So we're going to have x squared and x squared, and we'll alternate our signs in the middle. So that is one option, and perfectly fine to do it like that. The question is, what if I left it like this? How would I do the factorizing? Now, it is actually not so bad. All you have to think about is what times what will give me the part that I need. So that has got to be an x squared and a negative x squared, right? So those two there multiply to give me that. And then I've got to say to myself, well, how do I get a plus 4? It can either be a plus 2 and a plus 2, or it can be a minus 2 and a minus 2. Both of those will work. Now, does it make a difference? Let's have a look. So let's just check here and say, well, what happens if I multiply, do a little bit of FOIL? So minus x squared times x squared gives me minus x to the 4. That is going to give me minus 2x squared. Those will give me plus 2x squared. And that will give me plus 4. Now, the big thing to check is, do these two things cancel out? And yes, they do. And so I get exactly what I need. So we're pretty happy. Now, the question is, what would happen if I chose minuses here? Well, let's think about it. Let's just slot them in very quickly. If I made that a minus 2, maybe we don't need, and we made this a minus, then the only thing that would change this would become, so that one there would become a minus, and this one there would become, or is a minus and a plus, and all that would happen is, because I'm multiplying in a different order, that will become plus, that will become minus, and they still end up cancelling each other, and I'm still left with the plus 4 and the minus x to the power 4. So that's quite a nice one for you to remember, particularly because the order is different. So I'm just going to write here order, just so you can remind yourself that the order doesn't really make a difference, but if we can rearrange it to make our life easier, then we will do that. Right, let's have a look at another two examples, or another three. Still the same thing is happening, two terms, two brackets, x and x, y and y, and we alternate the sign. Just having a look at what happens if the variables are different. Now notice for me, we've got a power of 4, so this would then have to be a squared and a squared, but everything else is exactly the same. Right, next example. Now we've got numbers and a variable. Doesn't make too much of a difference. We can say, cool, question, is that a perfect square? Is that an even power? Is that a perfect square? Is there a minus in the middle? So my answer to all those questions is yes. So we're going to say 3y and 3y is how I get to the 9y squared. Alternate my signs. And how do I get to 121? Well, that's going to be 11 and 11. And there we have it. Nice and easy. Now, next example. 2 terms. That's my first question. Yes, I have 2 terms. Is there a minus? Yes. And my last question is, are they squares? And in this case, they are not, because 2 is not something times itself. The factors of 2 are only 2 and 1. So what we should look for is maybe we can take out our highest common factor first. And in this case, we're going to say, let's just rewrite it here, 2p squared minus 8x squared. I can definitely take out a common factor of 2, put it in the front. That leaves me with p squared minus 4x squared. Now, remember always with factorization, once you've done one factorization or you've changed the form of this, can we refactorize? And what's in my bracket is definitely something that I can factorize. So I'll make my 2 brackets, a p and a p, a minus and a plus, and a 2x and a 2x. And now I have something that is fully factorized. So it's a very nice example. You'll get these a lot in the test. Make sure you're always checking all 3 of these questions. Right, let's have a look at some more complex examples. So here we have ourselves a fraction and another fraction, but the questions are still the same. Is it 2 terms? Yes. Is there a minus in the middle? Yes. Are each of these things either an even power or a perfect square number? And the answer to all of those is yes. And so I'm going to open my 2 brackets, put a plus and a minus in the middle, and just look at each term individually. So the x squared will be x and x. The y to the power 4 will be y squared over y squared. And our numbers will 1 and 1. And what makes 9 will be 3 and 3. And there you have your factorized version just with a fraction. Okay, last 2 are a little bit more complicated. These are higher level. But the question is, now I've got a bracket and I've got another bracket. So the question is, let's separate them. Is the red bracket a perfect square? Yes, it is, because it has an even power. Is this bracket, the blue one? Yes, because it's got a power of 2. And don't forget the 4 also needs to be a perfect square. So there's 1 term minus 1 term. So still meets all our requirements. We just have to be a little bit more careful. So what I'm going to do is I'm going to use square brackets just to help us. And so I'm going to say, okay, there's a t minus 1. I've got 2 of them. So I'm going to put it 1 in each bracket. That solves that problem. Then on to the next term. Do not forget that we have that minus. Let's do it in something else there, right? So that's why I have those 2 things. Now I've got the 2. So the 2 comes from the 4, square rooting it. And then I've got the other t plus 1 and a t plus 1. Now, that's my factorizing done. But remember, we always want to simplify where we can. So that means I'm going to distribute that in there. So I'm going to have t minus 1 plus 2t plus 2. And I'll do the same in the other bracket. I have a t plus 1 minus 2t minus 2. And I'm going to collect my like terms. And in this case, I have a t and a t there, t and a t there, minus 1 and 2, plus 1 and minus 2. And let's see what that gives us. That gives me 3t, and 2 minus 1 is plus 1. And the other one is t minus 2t, so that's a minus t and minus 1. And so that, even though they don't look the same, which is what we're kind of hoping for when doing a difference of squares, this was my difference of squares. And then I simplified that out, collecting my like terms, and finally finishing up with something that is in the most simplified form that it can be. Right, and the last one, not too difficult, but just showing you how difference of squares can happen multiple times. So here we've got ourselves a little power of 8. So that means my first bracket will be x to the 4 minus 1, x to the 4 plus 1. Now, this again has two terms. It has an even power and it has a minus, which means that will go again into a difference of squares. So x minus 2 and a plus 1. And don't forget that can't factorize, but it's still part of our expression. So we bring it down. And we can say, but what about this one now that is also two terms minus even powers? So it can go to x minus 1, x plus 1, and then bring down anything that wasn't able to factorize further. And that is a nice long version, also something you can expect in a test scenario. Where we're testing, you remember we want to factorize and we want to simplify. And we're just going to repeat that process over and over and over and over again until we've got nothing left to factorize. So here we factorized, then we simplified, there was nothing to simplify, and then we check, can I factorize again? Yes, I can. And it came down. Same process, can something else factorize? Yes, it can. And we finish off with a nice long set of factors. All right, and thank you for joining No Wiki Maths. We look forward to seeing you again soon.